Mathematical logic and symbolic arguments provide a rigorous framework of evaluating arguments, identifying patterns, and constructing proofs by studying mathematical logic and symbolic arguments. We can gain a deeper understanding of the principles of reasoning and argumentation, ultimately leading to more effective communication, problem solving, and decision making.
You know what is arguments in mathematics?
It is the topic we discussed yesterday.
Argument is exchanging of diverging opposite views, typically a heated or angry one.
Yeah, that is argument. But argument in mathematics is when someone makes a sequence of statements and draws some conclusion from them. He or she presenting an argument.
Argument is composed or consists of two components. It is called hypothesis, premises, or initial statement, while the second is the final statement or called as a conclusion.
There are argument types. First is inductive statement. It is from specific to general, and deductive statement, which is from general to specific.
Argument is valid if the conclusion is true, whenever all the premises are assumed to be true.
Arguments is valid if the conclusion of the argument is guaranteed under its given set of hypotheses. Argument invalid if that's not valid argument.
There are four arguments symbolic form. First is the direct reasoning, and the second is the contrapositive reasoning. And the third one is the transitive reasoning, and the fourth one is the disjunctive reasoning.
Arguments in symbolic form. The first one is direct reasoning. P if a person is a human being. Q if a person is mortal. Premise 1. If a person is a human being, then he is a mortal. We have a specific example. Premise 2. Ben is a human being. In conclusion, therefore, Ben is a mortal.
Contrapositive reasoning. So this is contrapositive reasoning. Premise 1. P implies Q. If you brought biscuit, then you went to the grocery. Premise 2. You did not go to the grocery. Conclusion. Therefore, you did not buy biscuit. So this is contrapositive reasoning.
Another form of reasoning. Premise P implies Q. Second premise, Q implies R. Conclusion, P implies R. And this transitive reasoning. Example, P implies Q is, if Julia is a lawyer, then she passed the bar examinations. Q implies R. If Julia passed the bar examination, then she can be our legal counsel. Therefore, P implies R. If Julia is a lawyer, then she can be our legal counsel.
Disjunctive reasoning means that choosing between two options using the word or. In logic, we use PVQ, which means P or Q. This is true if at least one in the statement is true. For example, P, I will study. Q, I will sleep. PVQ, I will study or I will sleep. Deny one of them. Say one is false. Example, I will not study. So the conclusion, therefore I will sleep. If you deny one, this is disjunctive reasoning. One of the two options is true and one option is false. This is disjunctive reasoning.
Valid argument. An argument is valid if the conclusion is true, whenever all the premises is assumed to be true.
The fallacy of converse and the fallacy of inverse are two common logical fallacies that occur when reasoning is all about conditional statement of the invalid arguments. The fallacy of converse occurs when someone assumes that if P, then Q is true, then if Q, then P must also be true. However, this is not necessarily the case. For example, meaning then the streets are wet. If P, then Q. Invalid conclusion. If the streets are wet, then it is raining. If Q, then P. So it is invalid or not necessary. P of inverse. It occurs when someone assumes that if P, then Q is true, then if not P, then not Q must be also true. However, this is not necessarily the case. For example, it's raining, then the streets are wet. If P, then Q. Invalid conclusion. If it's not raining, then the streets are not wet. If not P, then not Q.